Hello, welcome to the second stage of this Geomagic Freeform online demonstration. In this video I'm going to show you how Geomagic Freeform can be adapted to use in healthcare and medical fields. So what you can see on my screen is a demo dataset. It's a patient skull with a number of defects. And what I'm going to do first is to try to fix most of them. But first of all, I'm going to tackle the potentially the biggest and the most difficult area to fix, which is the cranial defect. What I'm going to show you in this tutorial is a number of different workflows that I think they work pretty well. They might not be fully polished, as I'm just trying to go through the demonstration and show you as much as I can in a short period of time, as well as I'm not saying this is the only or the best way to do it, as then I bet there are a number of different ways of achieving similar results that I will do in this demonstration. So the way I'm going to tackle it is by creating a network around the defect, fill it in with clay and manually adjust it whatever I needed to, and then probably add a few manual final and detailed pieces to it. So first of all, I'm going to draw a curve around it. With that, I need to make sure that the curve will be fitted to my clay. I will do 3 points on the top, press E to end it, 3 points on the right, end it, 3 points underneath, press E, oops, go back, thinking ahead, drop it, press E to end it, and there we go. So what it is, I've got my curve drawn around. It has been vacuum fitted to the geometry of my skull. The curve also has got light blue color. That means it's a full closed loop without any gaps. Next one, I'll make sure that the fit to clay is deselected and that my sight window is open by pressing F6. I will drop my point somewhere in the middle of my curve and position my pencil in the middle of the defect in my main 3D window. Then looking at the top window, move it a little bit forward, so I'm working with my depth as well. Drop a pin and then connect it with the curve on the other end. Then it's just the sake of connecting all of those curves from top to bottom. There we go. Then I go to my select tool, click on the middle curve. What you can see now, I've got those arrows, and if I move them up, something like this will happen. What it shows, the red circle shows the tangency with the data. So by maneuvering with, by manually adjusting that curve, I'm making sure that it flows tangentially to the little bit of information that I've got around the defect. That's the best Freeform can do. So look at those curves, how they're flowing in 3D. They're not too bad. Obviously, as you can see, you can appreciate it. There isn't much data to base design off, but we'll definitely do our best to fit that in. Next of all, I'll make sure that they all split. So I'll select all of them from my object list as simply quicker. Make sure I've got my split intersection selected, click apply. As you can see, I've got so many more curves. Each and every section is a separate curve, as I will need that for the patch creation. Once it's done, I'll make sure I've got them selected one by one, such as this. So my surface, my patch is created. There we go, that doesn't look too bad. I've got my patches done, so I'll just go in, select them all, and stitch them, select them again, stitch them together. So I've got a single patch. The patch is just like a surface body. It's there visually, but it has got no thickness to it. So we can use it as a baseline of our design, but patch on its own will not really do much unless we close again, just like with our network, we force or we create a closed loop, then we can create a cut body of it from it. I've got one patch and I will use convert to clay method. Make sure again we select our patch. The thicken method is selected. 5 millimeters. Maybe let's change it to 8. Don't want any insert, don't want any overbuild. I don't want it to be flipped because that will go inside of our body. A new piece will be created. One thing worth mentioning under Advanced, it's good to select the volumetric, and I will show you why. I'll leave it on corners, filleted corners, and the thicken method as a geometric. And if I press create inside, as far as I'm aware, Freeform will come up with an error message saying you might want to check your settings. There we go, so that's what it just did. Unable to thicken, check following. The reason is we're trying to add the volume to it, but we're using wrong algorithm for that. So I changed the method to volumetric, keep everything as it was before, create inside, there we go. I can close that. And what I'm going to do now is go to view colors, make sure my show paint colors is deselected. That means that I can quite clearly distinguish between an active piece and not active piece. So right now our patch is active. Go up, choose the deform and torque tool. And this is a little bit of a manual edition, so you can probably wanting to do it well, you can spend quite a bit of time in here trying to adjust it. As all I'm trying to do is to get this patch flowing nicely and merging with those edges of the defect as well as potentially can. I'm not quite fussed what's happening underneath. I can stretch it, tug it, push it down, push it inwards, as it will be deleted anyway. But those edges that I try to get as accurately as I possibly can. So I want to make sure that that's it, fine gap between them. I'll make my tool smaller and just work on this specific area. Such as this. Down. There we go. Okay, so that's more or less it. Again, you can spend as much time as you want on it, trying to perfect it. Yeah, I think I've got nice selection there. A bit down. So it's like that. You look at it from slightly different angle, and oh yeah, this can be changed. This can be changed, and so on. Okay. So what I'm going to do, go to base school, go to base school model, and then remove from my piece tool. Click OK, hide the school, that's what we're left with. First of all, I'm going to go to select, make sure I've got my seat selection selected, click on main body, inverted, press delete, and then with this overhang, I think the best way would be to get rid of it using the polyline tool. So trying to follow geometry of our model. Once it's selected, press delete, reposition our view. Now I went behind the body, so that's gonna be a bit more difficult, but we managed to do it. That's it. Okay, that's really nice. Then we'll go to smooth, select it all. I want to preserve as much detail as I can, apply just a little bit of smooth. That's okay. I can bring my school up so I can see what's happening and how well it fits around the edges of the actual body. I think that's not too bad. Okay, so it looks pretty good on the outside. What I'm going to do next is just have a look on the inside as well. The way I'm going to do it is create a cross-section view by adding a plane on scope, position it through it just like this, then scrolling down to the Analysis tab, use the Define Cutaway View, and by default that plane will be selected for me. Okay, so I'll make sure I've got that accepted, then hide the plane, and that's what's happening on the inside of that model. So perhaps I'm just looking at this corner. If I'll go back to my tug, sure that my piece is selected, not my skull. I can then adjust it in. Again, that's not too bad. You can spend much more time on it as well, perfecting it. Okay, that's pretty good. I'll go back to the cutaway view, switch it off, and next what I'm going to do, position myself more or less straight above our implant, normal to our implant, create new plane, make sure that this plane is oriented flat to me. I'll go to sketch on that plane. We can switch those curves off as well, they only confusing us at this point. Minimize it, that's it, a little bit of housekeeping. And what we can add now, for example, I would just add a single hole, diameter, let's say, what are we working with? 0.6 of a millimeter coarseness, let's say 5 millimeters. Rectangular array, how many do we want? 5, maybe just one in that case. Oh, maybe 2, change it minus 10, and then we'll do that 10 as well, and then we'll just increase the number 6, 8. I think that's about right. Click apply. Okay, so we've sketched out number of holes. What I can do now is to go to my hybrid tools, extrude, then one by one, holding the shift button, I select all of these single sketches, go to next, make sure that my plane is completely, if I switch that off, there we go, it's completely cutting through the body which I'm working with, which it is in this case. I'm going to say not combine, remove from. There we go. So now what I'm going to do, change my view ever so slightly, add a new plane, position normal to my view. I'm going to sketch on it. Planes are infinite, so it doesn't matter that it doesn't cover the full area that I want. It will never end. So if I'll sketch again, around there, type in numerical value 5 millimeters, so I know it's controlled in a manageable way. Add the IA as well. There we go. If I drop it a bit lower because it was slightly too high, can't remember what we did last time. I think it was 10. Was it 10? Something like that. Okay. 8 to, that's fine. Apply, and I just repeat the exercise where I go to my hybrid tool, select each and every one of them, just like that. Press next. Make sure that it cuts through the body completely. The plane doesn't cut all the way through my body over there. However, the sketch does, so that's all I really care about. And remove. And there we go. So now I'm going to hide these planes, bring in my skull. That's our design. So obviously, understand this is quick and dirty method, but very quickly you can create something that's I think is half decent, and with a little bit more time on your hand and a little bit more practice, then you can perfect this workflow to actually get whatever you want to do. What else we can add? For example, this implant most likely wouldn't sit just on its own, as you can see, and most likely what will happen, there will be some sort of adjustments, clips, maybe screws added in, and you can bring in other card bodies. You can draw the card bodies, you can create them in freeform, it's not a problem, but it's obviously the problem with placement, so it does matter where do we actually put those clips in. So there's one really handy tool that we can use in Freeform to help us with positioning of such things. I'll make sure that my base skull is active again. I'm going to scroll down back to Analysis tab, which we've already used today, and say Analyze Thickness. Click onto that, select all of the skull, and choose maximum and minimal values. So minimum will be on 0 and the maximum will say 20, and I'll click apply. So that will take a couple of seconds and you will see shortly what it actually does. There we go. So what happened here, our model has been colored by thickness. So the green area is right in between the scale numbers that we've entered, so between 0 and 20. Anything closer to 0 will be blue, anything closer to 20 will be red, and off the scale will be white. So it's a fantastic representation of what we're actually dealing with. However, we can make it even better by using the ruler, and from Dynabar choosing measure thickness. So this is an interactive tool that once we hover over the body, it actually gives you the thickness of the material that you're working with. So as I'm hovering over the green area, I can see it's around 10 millimeters. As I go around the blue area, that drops to 3. We got 4. We got 2. Yeah, so obviously the bone down here is much thinner than the bone around here. If I hover over the white area, we've got 21, 28 in some cases, so much higher. I could quite easily go back and readjust the values. So if I press clear, and let's say I do 30 as my maximum value, click apply, wait for the software to calculate it. There we go. The colors look a little bit different now as the value is much higher. So for example, we get more blues, but again, it doesn't mean that immediately it's low. It just because the scale of our color bar is higher. There's more colors to include. So that's a really handy tool because it does allow you to plan a little bit better with obviously the patient geometry in mind. So how can we utilize it? We can, for example, use our axis markers. So if I'll go into that, I'll use the default one for the sake of this exercise. So you've got the diameter over 10 millimeters, clearance 5. Maybe I'll just change length to, it's always good to have it bigger. And the alignment mode surface normal. I've got my haptic bump, great. So what happens, I can feel the resistance from the haptic around here. I'll click once. As you can see, we've got one of the markers being dropped in. If I hover over it, will snap to the inside and then I can adjust it. As you can see, that will follow the normal direction of patient geometry. So let's say I'll leave it somewhere there. And then if I'll drop one next to it, and I will move around again. It follows geometry. However, what happens here, I cannot go any lower as it stops me because of my clearance that I said before. Let me just switch off the tolerance map so those will become clear. And make sure that if we go back up, axis marker, and under view, we would show paint colors. That's it. So I get my haptic bump from there. I cannot go any lower as it just stopping me. So I've got my inner diameter and then clearance away from that diameter. And that's exactly what's happening here as well. So it's a really nice way of positioning geometry or excuse me on some sort of reference points around the body. And again, I remember it was somewhere there. We could position it with the column up being active, move it around. Oh, go back there on the inside. There we go. Right now they both on the outside of our body. Great. So what else can we do with that? For example, we've got a pipe tool. We can very quickly just click on those. That will create a very simple cylindrical geometry where those axis markers can change the diameter to maybe 2 millimeters, so this is something much thinner. Add those as a completely new body, add them in. There we go, so they all added separately as new body. Once we've got those, we can then sketch out the design for custom clips. So if that's something that you will be 3D printing in metal, you can then take it away from this point, from this marker. I can 3D print the skull with those markers in, so I know exactly where those clips would sit. It's, in my opinion, in combination with the thickness analysis, axis marker comes really useful for this sort of work. I'm not going to sketch out any clips, but it can be done. It will probably take a little bit of time to do it accurately. Okay, so we've got that. Let's make our scope active again. So we've got one problem that we've tackled, which is the cranial implant. The next one that we work with is the orbital defect. And this way, this time, the way we're going to do it is by, first of all, finding the plane. There's my plane. That's exactly what I want. Then by going to select both, make it bigger, and what I'm going to do, I'm going to select the geometry of patient body on the right side that I will then use to mirror to the other side and use that for the implant design. Maybe a bit underneath. I will do that at the back as well. I think I've overdone it a bit, but so it's better to do too much than not enough. Sure, I've got as much as I can underneath as well. That's really useful. Okay, so what I'm going to do now is to copy this area, paste it as a new piece, so it's completely separate. As you can see, it's different color. Software is just implying to me that I've got two pieces, one on top of another. Oh, I made a miss. Oh no, apply as a new piece. There we go. With the newest iteration, there's one more step that we needed to do. As simple as that. Just make sure that, yeah, we want to add it as a new piece. Okay, so we've got that piece added in. I'm going to go to mirror. Make sure I've got that matched with my right plane 1. I want to mirror the entire piece, do the preview, click apply. Awesome. Switch that off. Okay, so I've got that piece selected. As you can see, I've got plane direct, like straight through the body, straight through the center of my skull. But obviously, human body not being perfectly symmetrical doesn't fit really well. So I'm going to go to reposition piece and select move clay, and then manually move that around as best as I can, really. It will not fit perfectly, so I just try to find the middle ground between what I have to work with and what I'm trying to achieve. Something like that, it's not too bad. So once that's done, then I'm going to use the talk tool again and adjust the body by simply stretching it to cover all of the defects. In the ideal world, this defect would be completely covered by the mirror, because we had the other cranial implant to create on the other side. There wasn't enough data to copy, so that's why I'll be stretching whatever I've got just to try to cover enough. Again, as you can see, this is something that you can spend quite a bit of time doing. Okay, getting it to the point where you're completely satisfied with with your results. So once the main defect is selected, I will go down and change and adjust the smaller area, and then to the top here as well. Also keeping patient aesthetics in mind. I can do probably with a little bit more changing as well. And then that area is completely not needed, so we can get rid of it by selecting it. I'll just go back to the select, and by simple polygon select, I can just cut that away. Delete. Delete that as well. And we've got this big piece to get rid of.